Hi guys, so today we are going to be doing Module 4, Chapter 11, Transformations, Symmetries, and Tiling. So let's get started with question 1. What is a rigid motion? Well, a rigid motion is a transformation of the plane that preserves distance. Now, there are a few different kinds of rigid motions, but we are just going to talk about 2 of them for this question. So this transformation is called a translation or a slide. You see how this triangle slides up here and is now right here. So it is called a translation or a slide. And now there is this transformation. You see how this F is right here, and here's the center, and it is rotated to right here upside down, and it is rotated 180 degrees. It is a half turn. So this is a rotation, and this is a translation. Now let's go to question 2. How many lines of symmetry do these 2 shapes have? So we have a diamond and we have a rectangle. So a line of symmetry is a line where we can fold the image and have both halves match exactly. If they fold over, they match. So our diamond has one line that goes down the middle, and these 2 halves can be folded over and they will match exactly. But it also has another line that goes from right here to right here. And if this is folded over, they will match exactly also. And for our rectangle, we have one line that goes right here, and then we have another line that goes down the middle. And if we fold these over, they will match exactly. So both of these shapes have 2 lines of symmetry. Question 3, what is rotational symmetry and what does it look like? So rotational symmetry can also be called a turn, and rotational symmetry is when a figure can be rotated 180 degrees around its center and it will look exactly the same. It also means that one point is held fixed and the other points are turned around the center of rotation through the same number of degrees. So this is what a rotational symmetry looks like with a triangle. See how this triangle is rotated or turned to right here, and here is our center point. So let's go to question 4. Is this figure a vertex figure? And if not, explain. So let's look at it. So we have an octagon, a pentagon, and a hexagon with the interior angles equaling 135 degrees, 108, and 120. So we have to remember that the measure of the interior angles meeting at a vertex figure must add up to 360 degrees. So that means we have to add up our interior angle degrees and see if they equal 360. So if we add 108 plus 135 plus 120, that equals 363 degrees. That means that we have a 3-degree gap right here. So this figure is not a vertex figure. Let's go to question 5. What is a dilation? So a dilation is also a non-rigid transformation. What makes something a rigid transformation is that the links between the points are reserved. And we are going to talk about non-rigid transformations for this question, and those links do not need to be preserved. One way to think about dilation is that we are just scaling the figure up or down. So I will give you an example. So we have a triangle right here, and we can scale this triangle down or we can scale this triangle up. And that is all a dilation is. Let's go to question 6. So why does this figure not have rotational symmetry, this figure right here? Rotational symmetry, as I said earlier, is when a figure can be rotated 180 degrees and look exactly the same. So as you see, we rotated this figure right here 180 degrees, and it looks like this. Before I rotated it, my base was long and my top was short, and after we rotated it, my base is short and my top is long. So after we rotated it, it does not look like the exact same figure, so therefore it does not have rotational symmetry. Thank you, guys.